Hello, so today we're going to look at special triangles. So let's have a look at our first question. So draw and label the three special triangles. All right, so what are these three special triangles? Let me draw three triangles, and they're all going to be right angle triangles. So our special triangles, if you remember, are right angle triangles. They all look kind of the same, but that's okay. All right. So let's start with the first one. So the first one, so I think we'll use degrees. We're going to have to choose a unit for our angles. We'll use degrees. It kind of looks like, let's say it's 45 degrees. So we know that in a triangle, the sum of the angles equals 180. So that third angle also has to be 45 degrees. So we have an isosceles triangle. So these two sides that make up the right angle are equal. They're actually have length 1, and by the theorem of Pythagoras, the hypotenuse equals 2. So that's one special triangle. All right, let's look at the second one. So let's say this angle is 30 degrees. That means this third angle is 60 degrees. And let's label our sides. So what do we know about the sine of 60 degrees? The sine of 60 degrees is root 3 over 2, which is opposite over hypotenuse. The cosine is adjacent over hypotenuse, which is 1 over 2. So this is our second special triangle. Now our third special triangle is actually, we have three special triangles. No, we don't. We have two special triangles and three special angles. So there's a mistake. Two special triangles and our three special angles. All right. Okay, so now that we have our two special triangles, well, that's embarrassing, but that's okay. Two special triangles, we have our three special angles. Let's look at the sine, cosine, and tangent of these three angles. So let's start with 45 degrees. So sine of 45 degrees, cosine of 45 degrees, and let's see if I can fit it in here, tangent of 45 degrees. So what do these values equal? The sine is opposite over hypotenuse, so 1 over root 2. Cosine is adjacent over hypotenuse, so again, 1 over root 2. And tangent is opposite over, is opposite over adjacent, so that equals 1. That's our first angle. Now our second angle, 60 degrees. Let's look at that one. Sine is 60, cosine is 60, tangent of 60 degrees. What do these equal? Sine of 60 is root 3 over 2. Cosine of 60 is 1 over 2. Tangent of 60 is root 3 over 1 over just root 3. Third angle, special angle, is 30 degrees. So sine of 30 degrees, cosine of 30 degrees, and tangent of 30 degrees. All right, what's sine of 30 degrees? 1 over 2. Cosine of 30 degrees, root 3 over 2. And tangent of 30 degrees, 1 over root 3. All right, so we have our two special triangles and our three special angles. Good. All right, so we're going to probably need these as reference for the following questions. So find the unknowns in the following triangles. Okay. All right, first question. So we have this triangle, the right angle triangle. We have some sides and some unknown sides. Well, we can definitely label the third angle because we know the sum of the angles in a triangle is 180. Okay, so now we need to find x. So if we use, let's see, what can we do? So we have a few things we can do. We can use the sine law, cosine law. We can use ratios, like for example, sine of 60 degrees equals, sine of 60 degrees equals root 3 over 2. Okay. So root 3 over 2, but it also equals, in this triangle, opposite over hypotenuse, so 3 over y. So now we can solve for y. Solve for y. What does y equal? Y equals, let's cross multiply. 3 times 2 equals root 3 times y, or y equals 6 over root 3, or what is that? That's 2 times root 3. So that's our y. That's pretty good. We have y now. Let's see if we can figure out x. So similarly, do we have space underneath? No. All right, let's move over. Scroll to the left. So cosine of 60 degrees equals 1/2, but it also equals x over y. Well, we know what y is. It's 2 over 3. So x over 2 root 3, and that equals 1/2. So let's solve for x. X equals 2 times root 3 over 2, or x equals root 3. We have solved our triangles. We have all the angles, all the sides. So first triangle is complete. Good. And we used our special angles. Okay, so let's look at the second triangle. Let's pick a different color. Looks like we have an equilateral triangle because all the sides are the same length. So that means all the angles are the same. So all the angles are 60 degrees. So we've dropped a perpendicular down from the top vertex. So that top vertex actually bisects, or rather that line from the top vertex down bisects that angle, that third angle, and we know that third angle is 60 degrees, so we actually have 30 degrees. Okay. So now we need to find x. So we know that perpendicular bisector, angle bisector, or side bisector is 6. So maybe we can use that in our special angles, from our special triangles, to find x. So why don't we use, let's use 60 degrees again. So sine of 60 degrees is opposite over hypotenuse of 6 over x, but that also equals, as we know, root 3 over 2. So now we solve for x. Solve for x. Let's cross multiply. And what do we get? We get 2 times 6 equals root 3 over x. We can divide both sides by root 3. And we get 12 over root 3 equals x. So that's the side length of our equilateral triangle. Good. All right, C. Let's have a look at this one. Okay, so in this case, we have a right angle triangle again. One angle is 45, and we know the sum of the angles in a triangle is 180. So that means our third angle is 45 degrees. So we know we have an isosceles triangle, so let's label that one side, or that side length that we need to find, as x. So we're going to use our special triangles again, and in particular the one with the special angle 45, and let's do sine of 45 degrees equals opposite over hypotenuse, so x over 8, but we also know from our special triangles this equals 1 over root 2, so now solve for x. Solve for x. So x equals 8 over root 2. So we can factor out a root 2. So 8 equals 2 times 4 over root 2, or 4 times root 2. So that's our side length. Great. All right, so, okay, this one looks more challenging. Let's see if we can figure this out. Now, so far, we've not used sine or cosine law. I'm not sure if you'll need to here in these exercises. And this is because we're dealing with right-angled triangles. Okay. So we have a rectangle, and the diagonal is 10, has length 10. We have this one angle, 30 degrees. That means this, this angle here must be 60. Whoops. Oh, making a mess here. Okay. 30, 60. Okay, so let's figure out x. Let's start with x. Okay. So how about sine 30 degrees equals opposite over hypotenuse, right? So x over 10. But the sine of 30 also equals 1/2. So then we can solve for x. Solve for x, that's a bright blue. If x equals 10 over 2, or x equals 5. Okay, so we have one side. Now let's figure out y. So let's see. How about we use, again, the 30 degrees, so cosine 30 degrees equals adjacent over hypotenuse. So adjacent is y over hypotenuse, and the cosine of 30 degrees is actually root 3 over 2. Right now we're going to solve for y. Let's cross multiply, so we have 10 times root 3 over 2 equals y. Cancel out a factor of 2 from the 10, we're left with y equals 5 times root 3. Good. Excellent. So again, we've just used our special triangles and those special corresponding angles. Okay, so now here we have, it looks like a rhombus. I'm just gonna, looks like we have two sets of parallel lines, and we have these little lines indicating that the sides are all the same length. We have one angle, 120 degrees. That means we have this other angle, since we have I think they're called supplementary angles. So 120 plus whatever this red angle is must equal 180. So that must be 60. Since we have a rhombus, that means this diagonal has bisected our angles. So actually equals 30. Each of the smaller angles equals 30. But we can also see that from our isosceles triangle here. Again, the sum of the angles in a triangle is 180, because we have an angle of 120. At this, let's call this vertex A. It's an isosceles triangle. These little angles in the corner must both equal 30. Okay, so now that we have that, this is x. Let's call our side length x. Let's see if we can figure out what x is. We have our diagonal. It's 14. I think we can use a cosine law. Cosine law. Right. So our cosine law, let's label some sides. Actually, let's call this vertex C. The 14 is side, we'll denote with the little, with this lowercase c. Then we have our sides. So from our cosine law, we have c squared equals x squared plus x squared minus 2 times x times the cosine of 120 degrees, or let's put angle C. Now let's plug everything in. So our side C length is 14. We don't know what x squared is or what x is. And we know what angle C is. It's 120 degrees. Okay, so let's factor out this 2x squared. 1 minus cos 120 degrees, and then we have our 14 squared. So we may or may not be able to. We may or may not be able to figure out this exactly. Let's see. Okay, 196. All right, so what's a cosine of 120 degrees? All right, let's scroll over to the right, and this is where we're going to use our cast rule. Cast. 120 degrees is in the second quadrant. Related acute angle is 60 degrees. So the cosine of 120 degrees equals negative the cosine of 60 degrees. What's a cosine of 60 degrees? 1/2. So cosine of 120 is negative 1/2. So let's plug that in there and see what we get. 2x squared times 1 minus negative 1/2. So 1 plus 1/2. Okay. This equals 2x squared times 3/2. Cancel out the 2, and we have 3x squared equals our 196. All right, so let's just rewrite this. 196 equals 3 times x squared. All right, so 196 divided by 3 equals x squared. Take the square root of that. Let's see if we can do this. 96 divided by 3. And it looks like x equals 8.083, or at least approximately. Or we can just rewrite it as 196 divided by 3, and we take the square root of that for x. So now we have the side. We've calculated the side of our rhombus using the cosine law. Excellent. So that brings us to the end of our session today. Special triangles. We had one example with the cosine law. If you have any questions, feel free to send us a note at info@raisemymarks.com or give us a call, day or evening, and we will be happy to help you. Thank you for watching, and we look forward to seeing you again.